Welcome to our brand new chapter on graphing trigonometric functions. This first tutorial, we will be graphing sine and cosine functions. We will only be changing the amplitude and the period at this stage. We'll also throughout be labeling appropriate scales on the x and y axes. So I know we're still in chapter 5, but I like to think of this as a second half of chapter 5 in terms of the graphing. So just so you know, we're going to be graphing everything in radians. We're off of degrees, hopefully, and we're into radians. We're looking at sines and cosines. To sketch the sine and cosine curves, what we're going to do is we're going to find 5 key points. And I believe that the easiest way to find those 5 key points are at the 5 easiest angles along the unit circle. And what angles I'm talking about: 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi, which I know is the same thing as 0 pi. 5 angles: 0 pi, pi over 2, pi, 3 pi over 2, and 2 pi. At those angles are the ordered pairs 1, 0, 0, 1, negative 1, 0, 0, negative 1, and of course back to 1, 0. So these are pretty easy points to graph. If we're talking about the cosine curve, then we're looking at the x coordinates, and we'd be graphing the points 1, and then 0, and then negative 1, and then 0, and then 1, and then 0, and then negative 1, and then 0, and then 1, and then 0, and then negative 1, and then 0, and it can continue on forever. But it's just those 4 values: 1, 0, negative 1, 0, 1, 0, negative 1, 0. If we're talking about the sines, then of course we're looking at the y coordinates, and we'd be graphing 0, 1, 0, negative 1, 0, 1, 0, negative 1. So let's explore that. I'm going to first look at the sine curve. So we're talking about the function y equals the sine of x. So we're going to generate a t-table first. So we're going to get x, and then we're going to get the sine of x over here. So we just said that the 5 key points, the 5 easy angles, we're going to use 0 pi, we're going to use pi over 2, we're going to use pi, we're going to use 3 pi over 2, and we're going to use 2 pi. The sine value at each of these angles, the sine of 0 pi we saw was 0. We're looking at the y coordinates, 0. And then at pi over 2, the sine is 1. And then at pi, we're back to 0. At 3 pi over 2, we're at negative 1. And back to 2 pi, we're at 0. This is just a quick t-table to start a sketch of the sine curve. Okay, so now let's figure out how we're going to graph these 5 key points. We've got our graph here. On the x-axis, we're going to be putting all of our angles. Now, I want everybody's x-axis to look identical. From the origin, we're going to count 1, 2, 3, 4 tick marks, and we're going to put pi right there. That means that 8 tick marks away is going to be 2 pi. Every 4th tick mark will be pi. Now, up and down the y-axis, I'm going to give you a little bit more leeway. Usually, I just go up to the 2nd tick mark and make that a 1. So the 2nd tick mark down here would be my negative 1. But I'm going to give you a little bit more leeway for your y-axis. But everybody's x-axis will always be identical. And I will explain a little more about that later. Every 4th tick mark is pi. Every 8th tick mark is 2 pi. There are only 2 exceptions to this rule, and I will explain those exceptions when we get to them. Otherwise, every 4th tick mark will be pi. That means that every tick mark is representing pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay, so now let's start to put in our ordered pairs. I've got 0 pi, 0. That means 0 pi, I'm not moving left or right, and I'm not moving up or down either. Actually, 0, 0 is one of the points on our sine curve. Pi over 2 and then 1. Pi over 2 would be exactly halfway, or 2 tick marks, and then we're going to go up to a 1. So there's our 2nd point along our curve. Pi, 0, is our 3rd point. Pi is right here, and 0, of course, is we just stay right there. Our fourth point, 3 pi over 2, negative 1. 3 pi over 2 would be 1 pi over 2, 2 pi over 2, 3 pi over 2. It's exactly halfway between 1 pi and 2 pi. And then we go down to negative 1. And then our final point will be 2 pi units and then back to 0. So 2 pi units is right there and then 0. These are the 5 key points. And I hope that it makes sense that this is what the curve is going to look like. It is a curve. It is not a Charlie Brown sweatshirt just zigzags. It is a curve. So we're curving up to this and then we're curving down to this one and then back up. That is called one period of the sine curve. We could, of course, continue this pattern indefinitely, but I don't want you to. If you are going to do that, I'd prefer that you, let's go, it would be about right there and right there. If you're going to, I'd like you to do it with a dotted line. It's going to be very important for me to know that you know what the first period of the sine curve is. I'm going to continue the curve just so we can talk a little bit more about it. Here, here, and here, but I'm going to dot it in. When we get to our practice sessions, in the back of the book when you're checking through your answers, they actually graph as much as they can, which might start to be confusing because I just want one curve, one period of the sine curve. Okay, I know that how I like to think of the sine curve, it kind of looks like an S to me. If you're looking at it sort of sideways and flipped over, it's sort of like an S, like a Superman S. And that makes sense to me because it is the sine curve and sine begins with an S. So I always think that the sine curve looks like an S as opposed to what I'm going to see in the cosine curve. So it looks like an S to me. I would like to talk about domain. I would like to talk about range. And I have one other question. If we're talking about domain, the domain is all reals because this graph continues on forever, all the way from negative infinity all the way to positive infinity. So the domain of this is all reals. You can do it as a set or you can do it negative infinity to positive infinity, whichever one you personally like. In terms of range, now I'm looking up and down. The lowest that the range values get are right down here at the bottom of this valley, which is -1, and the highest that the range values get are as high as the top of the peak, which is +1. So the range goes from -1 to +1. I do get to include those endpoints, so I'm using my brackets. My one last question is this an even function or is this an odd function? It's helpful that I went and continued the pattern this way so that we can see that this indeed is an odd function. If I rotate this function 180 degrees upside down, if you take your note sheet right now and flip it upside down, you're looking at the same exact graph. This top of the peak would rotate 180 degrees to be this bottom of the valley. This is an odd curve. It's important to note that the sine curve is odd. Let's do the same sort of thing for the cosine curve. I'm going to generate a t-table, same t-table, well, not the same t-table, but the same setup for the t-table. We'll have the input, and then we'll have our output, which will be the cosine. Our inputs, again, are the 5 easy angles, 0 pi, pi over 2, 1 pi, 3 pi over 2, and 2 pi. This time, I am looking at the x coordinates from our original drawing that we did on the front page. The cosine of 0 pi is 1. And then I'm looking at the x coordinates. Pi over 2, the cosine is 0. And then -1 is the cosine of pi. And then 0 for 3 pi over 2. And then back to 1. I'm going to plot these 5 points, and we have the same exact reasoning with our x-axis. 1, 2, 3, 4 tick marks will always be pi. 8 tick marks will always be 2 pi. There are 2 exceptions to that, and I'll tell you about those in a minute. Up here to a 1, down here to a -1. I'll give you a little bit more leeway on the y-axis, but I typically go up 2 tick marks to get to the 1, just so I can use a bunch of the graph paper. Okay, so let's plot these points. 0 pi and then 1. So 0 pi, the cosine curve starts all the way up here. Pi over 2, 0, that's 2 tick marks over, and then a 0. Pi, -1, that's 2 more tick marks, and then down 1. 3 pi over 2, 0, 2 more tick marks, and then 0. And 2 pi 1, that's 2 more tick marks, and back up to a 1. This is a curve. This is not an absolute value. If we plugged in all the other angles in between all of these easier angles, we'd find that the curve does this. This is the top of a mountain, and it's curving down to the valley, and it's curving back up to be part of the top of the mountain like that. And there's your cosine curve. That's one period of the cosine curve. I can continue this pattern a little bit more, and I'm going to do that if I dot it in. I really do not want a solid curve here, because then I might be confused and you think that it continues on. I just want one period of it, and that'll start to make more sense as we start to graph these things. But I am going to go ahead and do that just so we can talk more about it. I think that this one looks like a C. You kind of have to tilt your head to the side, but it kind of looks like a C. So now I see that the cosine looks like a C, right? At least from the side. If you look and tilt your head, it looks like a C, and the sine curve looks like an S. So that's the dead giveaway for a sine curve looks like an S to me, and the cosine looks like a C to me. So there you go. So I think it looks like a C. I'll put a question mark. I know it doesn't really look like a C, but closer than any other letter to help me with cosine. Let's talk about domain and range. It's going to be exactly the same. The domain, I can plug in anything I want for the x's, so all reals, or you could do your negative infinity to positive infinity if that makes more sense to you. The range, same exact thing. As low as we get is -1, as high as we get is +1, and I get to include those, so I'll use my brackets. But my question to this one is this an even function or is this an odd function? This time, and again, it helped that I continued the pattern. This time we have an even function, because the even functions are the ones that fold along the y-axis. So this point folds to become this point, and this point right here folds to become this point. It folds directly over this y-axis, so that's why the cosine is an even function. Okay, so now we've seen what the basic curves look like. Let's talk about the two pieces that we're going to be focusing on today that are going to change what our curves look like. First, I keep using the word period here. These graphs are periodic. They're called periodic graphs because the pattern continues forever. The pattern continues forever. The period for the cosine and the sine is what? Let's go back and look at either one of the graphs because they have the same period. How often is it until these graphs start to repeat the same points again? Well, I'm going to start with the very first thing. It takes all the way until we get back to here before it starts to repeat again. And then it's going to be another C right in here, and then another curve right over in here. So it takes exactly 2 pi units for this curve to start to repeat itself. Look at the sine curve, and it's the same exact thing. We go up and then down, and then we start to do it again. Up and then down, and then we would start to do it again. And so this is exactly 2 pi units again. 8 tick marks. So the period for each one of these is 2 pi. That's the normal period. That's how long a curve normally takes for the sine and the cosine. Okay. So we have our standard form. We have 4 variables that we're going to be looking at eventually, but right now we're just going to be looking at a, which is the coefficient of your main function, and b, which is the coefficient of the input, the coefficient of your angle. We'll explore c and d later on. Right now we're just looking at a and b. So let's talk about a first. A represents your amplitude. It will always be the absolute value of the number that you see there. A is the amplitude. Amplitude sort of reminds me of altitude, and that sort of reminds me of height, and that's exactly what the A does. It affects the height. It's going to affect how tall your graph goes. So when you're talking about amplitude, you're always talking about a positive value. Amplitude is a positive value. I understand that sometimes you're going to see a negative number out here. That doesn't mean that the amplitude is going to be negative. The amplitude will always be the absolute value of the number that you see here. The negative will just flip the direction of your ordered pairs. It'll flip the direction of your opening. It'll flip it upside down. But the amplitude will always be a positive value. So we'll discover what amplitude does on the next slide. The other thing that we're going to be looking at today is what the value of B does. And the value of B affects the period. Normally, B will be a value of 1. And we like when B is 1 because then the period is not affected. It's still just going to be 2 pi. But if you have any other value of B, you're going to take your normal period of 2 pi and you're going to divide by whatever B is. That's how B will affect your period. And we'll see what that does a couple slides from now. So we're just looking at A and B today. Here are our first 3 graphs. All 3 of them are cosine curves. So all 3 of them generally will look like a C. And if you notice, we're just doing a little experiment. We're just changing the coefficient of each of these. Right here it's a 3, here it's a 1/2, and here it's a -2. This is going to be our amplitude page. We're going to be changing the amplitude for each one of these. Okay, so let's look at this first one. I want to know what the amplitude is. I'll call that amp. The amplitude is changed. It's a 3. So that means that this graph is going to be 3 times as tall. I would also like to know what the period is, but since we're not changing the period at all in any of these 3, I know that the period is going to be 2 pi. The value of B is just a 1. It's the number in front of our variable, and that's just 1. So 2 pi divided by 1 is still 2 pi. So that's not going to change our period, but the amplitude will change. Let's start to label our axes. 1, 2, 3, 4 tick marks over, and that will be pi. 1, 2, 3, 4 more tick marks, and that will be 2 pi. I know that my amplitude is changing, and I know that normally I go to the second tick mark and make it a 1. And I know that that might be frustrating a little bit because we're actually going to be going 3 times as tall. So if this is a 1, then 2 is going to be right here, and then 3 is going to be way up here. But that's okay. It just comes off the graph patch a little bit. Here's -2, and then -3 will be right down there. So I have to make sure that my labels are correct. Please make sure you're labeling both axes, the x and the y. Okay, now let's put in our ordered pairs. This is a cosine curve. Normally the cosine curve would be 1, 0, -1, 0, 1. In this case, we're going to be going 3 times as tall. So instead of starting at a 1, we're actually going 3 times as tall. So we're starting at a 3. And then we go 2 tick marks over, and then we're at 0. And then we go 2 tick marks over, and then normally we'd be down -1, but this time we're all the way down -3. And then 2 tick marks over, and we're at 0. And then 2 tick marks over, and again, we normally would be at the 1, but in this case, we're all the way up at the 3. Here's our cosine curve. Let's see if we can curve it on in here. That's been stretched 3 times as tall because our amplitude has changed to a 3. If we look at the second one, now our amplitude is 1/2. 1/2. Our period is still the same. It is 2 pi. 2 pi divided by 1. Let's get our scales. 1, 2, 3, 4 tick marks will be pi. 1, 2, 3, 4 tick marks will be 2 pi. I like to go to the second tick mark to make it a 1. There are some times that I will change this idea, but I try not to change it every single time. I like to try to stay consistent. I know this was kind of annoying that we were off the patch a little bit, but that's okay. It's not like it were 5. If it were 5, I probably would have counted by 1 tick mark. Like I said, I'm going to give you leeway on the y-axis. But if you change your scales on the y-axis every single time, then it might be difficult for you to see what amplitude actually does to your graph in the stretch. So I'm going to try and stay consistent as much as I can. Okay, it's still a cosine curve, so it's still going to look generally like a C, but we're only going up half as much as we normally would. So when we normally start here at a 1, this time we start at a 1/2. We go 2 tick marks over to get to our 0. We go 2 tick marks over. Normally we're down 1, but this time it's just a half as much. 2 tick marks over, we're at the 0, and 2 tick marks over, we're back up to 1/2. And there is our tinier cosine curve. It's only half as tall as it normally would be. Still kind of looks like a C. And we've got one more on this page. I'm looking for amplitude. This one gets some people because they say the amplitude is -2. The amplitude will always be the positive value. So the amplitude is 2 because it affects the height. We're twice as tall. Now I understand that there's a negative sign here, and maybe you make note of that because the negative is going to do something. It's just going to flip the C upside down. But the amplitude is a positive value. Okay, and the period does not change. The period is still, 2 pi over 1, so it's still 2 pi. I'm not changing period yet. That'll be the next slide. Let's get our scales going. 1, 2, 3, 4 units over is pi. 1, 2, 3, 4 more is 2 pi. I know you technically don't need to label both of these. It just helps me to do it. Once you've labeled the first one, everybody knows exactly what you're counting by. But I like to label both of them. It's just easier to count for me. I know that the amplitude is 2, so I'm still good with my normal scales here, going up 2 tick marks to a 1 and down 2 tick marks to a -1. Same thing. I know you don't need both of these. One of them is enough, but I don't want you to miscount, so having more tick marks is probably better. Okay, so our amplitude is 2, which means we are going to be going twice as tall, but we are going to be going in the opposite direction. So normally we'd be starting up here at this 1, but because of the 2, it'd be twice as tall. But because it's negative, we're actually starting all the way down here, the exact opposite. We still go 2 tick marks over to get to a 0. We still go 2 tick marks over to get to the next one, which normally would be down here, but because it's opposite, it's going to be way up here, twice as tall. 2 tick marks over, we get to a 0. 2 tick, and of course 2 or -2 times the 0 doesn't change 0. 2 tick marks over, and again we're normally up there, but this time we're down here, and we can see that our C, which is a curve, so please make sure you're curving it, is upside down, and this time it looks maybe like a bell or a ghost. So if we wanted to review some range, because really the domain for all of these is still all reals, but if we wanted to look at the range has been affected. We see that now the lowest we go is -3 and the highest we go is +3. So our range has been changed to -3, 3 with brackets. Over here, our range has changed to -1/2, comma, +1/2. And over here, our range has changed to -2 to +2. The lowest we go is -2, the highest we go is +2. So you can see that amplitude will affect your range. So now that we've seen what amplitude can do to your graph, let's see these last 3 and affect the period of our graph. If you notice, our amplitude is not going to change anymore. Our amplitude is back to our normal 1 and 1 and 1, okay? But the value of B has changed from a 2 to a 1/2 to a 3. So let's see what that does to our graph. Okay, so the first one, we're looking for amplitude and we're looking for period. Of course, amplitude does not change, it's still just a 1. The period this time has been changed. 2 pi, which is normal, will be divided by 2. So in this case, our period is pi. What that means is our curve needs to be finished by the time we get to pi units, as opposed to normally when we get 2 pi units to finish it. Pi is going to be the new period. The entire S curve has to be finished by pi. Let's label our scales. 1, 2, 3, 4 units is pi. 1, 2, 3, 4 units is 2 pi. 4 more units is 2 pi. I'm going to go up to the second tick mark and make a 1 and a -1 at the bottom. So what I'm saying now is, since pi is our new period, the S curve does not get to take the entire 2 pi units. We have to actually finish it between 0 pi and 1 pi. So what we need to do, we need to change what we're actually counting by. Normally we're going over 2 tick marks, 2 tick marks, 2 tick marks, 2 tick marks. This time we only get to go over 1 tick mark, 1 tick mark, 1 tick mark, 1 tick mark, because we've been cut in half basically. So it's a sine curve, so it's going to look like an S that starts at 0, 0. And now I'm going to go only 1 tick mark over and then up to a 1. 1 tick mark over to the 0. 1 tick mark over down a 1. 1 tick mark over and stop. And that is where our curve will be. So basically what happens is we take our new key points. Whenever the period is changed, we have new key points. We take our period and divide it into fourths. That's basically what's happening. Because ultimately what we're doing with our period is dividing it evenly into 4 spots so we can get 1, 2, 3, 4 points. I know that there's a 5th point here at the beginning, but we don't count that one. 1, 2, 3, 4, and we need to evenly space them throughout our period. Basically take your period and divide by 4. So in this case, since our period is pi, if I divide that by 4, I get pi over 4. That's why I'm counting by pi over 4s. If I take my normal period of 2 pi and divide that by 4, 2 pi divided by 4 is pi over 2. That's why I'm counting pi over 2 units to get to each of my new key points, or old key points. So this is a good concept to understand. To find any key points, take your period and cut it into fourths. Or you can take the distance that you need to travel, cut it in half, and then cut that half in half. That'll get you to the same thing. Okay, so it's a little curve. Now you can see that actually we could fit 2 sine curves in the entire regular normal period, right? There's one little s, and then there would be another little s. And there's 2 of them that can fit in there because b is 2. So that's kind of neat. Looking at the next one, amplitude, well, that's not changing. That's just a 1. But my period normally is 2 pi. This time I'm dividing by 1/2 because b is 1/2. 2 pi divided by 1/2 is the same thing as multiplied by 2. My period is now 4 pi. This is now stretched out 4 pi units. Let's see what happens to our scales. I don't know what happened there. Okay. Click that. So 1, 2, 3, 4 gives me pi. 1, 2, 3, 4 more gives me 2 pi. I'm only halfway where I need to be. 1, 2, 3, 4 more will give me 3 pi. And yikes, I'm going to be off the patch a little bit here. So 1, 2, 3, 4 more tick marks will get me to 4 pi. I know that this may be frustrating, but this is no reason to change the scales. It's still easy with the 4th tick mark being pi for me to see where 4 pi is. Well, I just might need to go off of my graph patch a little bit. This is not one of the exceptions. I'm going to go to the 2nd tick mark and make a 1 and make my -1, and now let's see what happens. I'm graphing in blue. I'm going to find my new key points. My new key points are taking my period and cutting them in fourths. So that means I'm counting pi units. I'm counting pi units to get to each of my key points. So 0, 0, of course, that's where my sine curve always begins. I'm going pi units over before I get to go up to the 1. Pi units over before I go back to the 0. Pi units over before I go to the -1, and then pi units over, and I will go back to my 0. That is a stretched out sine curve. Again, how did I know that I'm counting by pi? I'm taking my period and dividing it equally into 4 installments so that I know that I can equally divide this throughout the period. Or I can cut my period in half and then in half again to get to what I'm supposed to be doing. And if you notice, this is my normal period, 2 pi. How much of my sine curve is in here? Only half of it. Why is only half of it in here? Because b is 1/2. Why could 2 fit in here? Because b is 2. So that's kind of interesting. My last one, amplitude, that's 1. My period is now 2 pi divided by 3. Okay, this is a very interesting period because this is going to yield one of our exceptions. If you were counting normally, fourth tick mark is pi, eighth tick mark is 2 pi, can you see where 2 pi over 3 would be? You could probably imagine where it would be. It's approximately in here, but the point is it's not on one of these nice tick marks because this is not really useful when we're talking about fourths. This is nice when we're talking about sixths or thirds. So what I'm going to allow you to do when the period is something that is not really useful in terms of fourths, I'm allowing you to change your x-axis slightly. 1, 2, 3, 4 tick marks is normally what we do for pi. This time we're going to go to 6 tick marks. It's a little bit off, I understand, but it's going to be a whole lot easier to find 2/3 when you're talking sixths than if you're talking fourths. So this is one of the exceptions to our scales on the x-axis. You're going to find another exception when we do practice in class. So 1, 2, 3, 4, 5, 6 tick marks will be pi, and 1, 2, 3, 4, 5, 6 more would be 2 pi. I'm still going to the second tick mark to make a 1, and the second tick mark to make a -1. Now I'd like to know what we're counting by. So I'm going to take my period of 2 pi over 3, and I'm going to divide that into fourths. Well, that's a little bit more involved math. 2 pi over 3, I'm going to multiply by the reciprocal of 4, which is 1/4. So I'm getting 2 pi over 12, or rather pi over 6. That means that I'm counting by pi over 6. Each one of my little dots is going to be pi over 6 units away. It's still a sine curve, so it's going to be looking like an S. So that's 0, 0. And then 1 tick mark over, that's the pi over 6, because I used 6 tick marks. This is pi over 6 before I can go up to the 1. Pi over 6, one more tick mark, and I'm at my 0. Pi over 6, one more tick mark, and I'm at -1. Pi over 6, and I'm at 0. That is now my sine curve. And if you notice, I didn't quite even get to 1 pi. I knew that because my period is 2 pi over 3, 2/3. I went 1/3 and then 2/3, and I stopped shy of my 3/3. So my period still is 2 pi over 3. The point that I want to make about your scales is I cannot just let you change your scales on the x-axis whenever you want to. Because if you do, then all of your graphs will look the same. If you look at part A and part C, forgetting the scales, those graphs look identical. And that's the danger that some students get into when they start changing their scales just to suit their needs. That's why I want to force you to always have the fourth tick mark be pi. I'm going to allow an exception because it's kind of difficult to find 2 pi over 3 or even pi over 6 in this set of scales. So I'm going to allow you to change that sometimes, okay? Not often. But if you do that every single time, then your graphs will all look the same and you won't really see the accordion effect that B does to your curves. So we'll practice this. I know that we're going to need some practice in class with graphing. Get some graph paper from the store and bring it on in, and I will see you in class. See ya.